So hi everybody. My apologies for the late late notifications on a change of times. First, I wanted to open with the fact that, as you probably saw in the email, we're going to be changing our meetings to this time slot to be happening every week. Our sort of last year's experiment of doing morning meetings every other week in order to attract more remote attendance, potentially from other geographies, has proven to be a little bit unsuccessful. As a matter of fact, we've lost some local attendance rather than gain more. So we're going to be simplifying. And if there is, if other geographies have some special needs for presenting during different time slots, we can certainly accommodate it. But the running times will be from 4 to 5 Pacific Standard Time or Pacific Daylight Time.
Which, by the way, should be good for Asia.
Should be, yeah, for Korea and Japan. So, yeah. Maybe not so much for India. But
yeah, it's big. Yeah.
All right. So today, look, I provided 2 separate topics. So I'm going to pass in the baton, and you can drive the presentation from there.
Yeah. Hi, everybody. So, let me see the agenda. Well, anyway, I guess I know what to say. So for the first topic, I'll talk more about the second one, but for the first one, I just want to give you some high-level context and then leave E, mainly, and Pierre to provide more details. So, essentially, we are trying to manage to write flows on control the action switches with the intent framework. To do that, we are doing, of course, different modifications. One thing we miss is that when we compile intents into flows, the flow objectives, those flow objectives just write flows on the devices, simple flows, and they don't use groups. So probably an hack, we are not sure, but what we did for now, I'm not sure everybody knows it, but we have an option today to say, instead of common flows, compile into flow objectives, true or false. Okay, in case that's true, essentially we use another compiler and we create flow objectives instead of flows. Simple enough, I guess. So the decision was either modifying the existing flow objective compiler, but that would have broken lots of existing drivers and stuff, or what we did for now was just create a third compiler which creates flow objectives that use groups. Did I say that correctly? Yeah. Fair enough? Correct enough? Yeah? Okay. So I'm not sure if we are not sure if this is too much a hack, if it's dirty, if there's something better to do. Any thought?
Well, it seems like, I mean, if you're going to be using flow objectives, meaning you're going to be using different pipelines, meaning you're going to be taking advantage of 1.3 and different capabilities, you ought to be, by default, using groups. For
sure, except
for certain intents, which need to like broadcast intents, right?
Well, except in the reality, unfortunately, not all the switches support groups, which I know is a problem of the switches that don't follow what it should be done correctly, but at some point we need to deal with the reality and we need to deploy also, right? So I mean, there's the need to deal with some switches that don't use the group.
Okay,
well,
so this will be the point where we have drivers, right? I was just going to say that, exactly. Exactly why we have drivers. If this is something that needs to be changed from a device to device, then we need to probably have that. Exactly what Charles said.
Well, the other thing about groups is that you could, for a device or a driver that didn't support groups, instead of actually writing the group down to the device, you could just keep the group virtually and then just perform a rewrite of the flow rules that come through and inject whatever actions the particular group had into the rule that gets pushed down.
We have pipelines that do that. Like the software pipeline does that. Takes the groups and just throws them, and then the flow rule, but with the actions of the group in the flow rule.
Cool. So that's a good thing to know.
So it seems like leverage, like what Thomas said and what I agree with is we should leverage the full suite of capabilities, devices that happen to be able to support that.
And put the acts, let's say, or anyway, the transformation of the full capabilities for specific devices inside the drivers.
Yeah.
Now, is it sufficient to be absorbed inside the pipeline driver, or do we need to have a separate sort of capability of abstraction outside of that? Because right now the compilers themselves just direct flow objectives, which get routed through the pipeline driver, hidden behind the flow objectives.
Yeah.
Forwarding. Sorry. Yeah. More on it. Yeah. What did I say? Flow objective.
You mean they specifically push floating objectives, right?
Yeah. Okay. I wasn't making a distinction between which kind, but yeah. But they push flow objectives downwards. Okay. Forwarding them. Is it enough for the? Is it enough? Can the pipeliner apply the appropriate differentiation based on device capabilities behind the scenes, or is it something that needs to be spelled out more explicitly from within the compilers and from above the forwarding objectives, meaning the group management, for example, right? Because Brian alluded to. What is it enough to? Can pipeliner hide it completely? Because if that's the case, that would be a simple solution, right?
You mean the thing of
whether or not
the pipeline, whether or not use groups. I don't know. I think it probably can, because groups are basically just bits of action, right? If you don't want to actually push a group to a switch, then you can always take those actions and put them in a flow rule.
Well, but the problem is that is forwarding objective the right one we should use to create groups? Because at least as far as I know, OTPH driver or pipeliner doesn't expect this, right? We expect those groups in the next objective.
Yeah, what the proposal would be to change the intent compiler to use the next objective, right? And then have the driver take those next objectives and merge them together with the forwarding objectives to get close and switch to the objectives.
But the compiler,
assuming that, well, so in cases where you have groups on device, the next objectives could just be written down to the group table. In cases where you don't have group support, the next objectives would be merged with the forwarding objective to create flow rules that have the embedded actions.
Yeah, like I said, we have an example of this. There was one of the hardware intake or something that didn't have any groups that I was using. We also have the software pipeline, which takes the next objectives and that's
So, okay, sorry.
I'm not sure that would work for every single possible case, but it's probably the best thing to try to start with.
now,
So sorry. My only concern with this thing, but I could be completely wrong, is that, so let's say we modify then the existing compiler, right, to do the right thing, to just write groups as it should happen.
to write the proper objectives, right? Properly structured types of objectives.
Yeah, right. Anyway, to make use of groups in the driver, you're sending down an information that says basically use groups, right? Or it's still already abstracted.
You would be sending different kinds of objectives, yeah.
Okay, whatever modification we do to the existing driver, the question is, wouldn't this break all the existing drivers? So my question is, should I go then driver by driver for this and implement the driver of everyone to do this modification, or?
Theoretically, the drivers are already going to have to deal with next objectives. So there's three types of drivers you're going to find. Type 1 of drivers is group tables supported, the next objective is supported in the pipeliner, and there'll be no problem. Driver number 2 is the one type of driver that Jono talked about, where they'll implement the next objective on hardware that can't support it and do the merging already. Driver number 3 is people may have implemented drivers where they just said, I'm not going to use the next objective, I'm just going to use forwarding objectives for my application. And they may be deficient in that they just don't support a type of objective that we care about. So in cases 1 and 1, in case 3, implementing the right behavior on those drivers would be an improvement to those drivers, which would not only help the use case of the intent framework, but also applications that want to use flow objective tree.
Makes sense. The question was just if I had to spend more time on implementing the drivers of other people for other use cases, or
well, the thing is, if you want to create a third compiler that uses the next objectives to get groups, then you're already creating the driver that is going to map those next objectives to the open flow rules that need to happen.
Because you would already have to be concerned with the fact whether the device supports them or not, the groups.
Well, sure, but I still leave the decision to people to use either the common compiler or to use the new compiler, right? In case they want to use the new compiler.
It's a big system-wide switch that you're having to throw to change behavior. So I think it would be better to augment the existing, and it's more in the spirit of how flow objectives were supposed to be used. My only question, Charles, I asked earlier was, so this sort of ability to merge, let's say, next objectives with previous forwarding objectives was to, it can be done even if the objectives arrive separate requests, right? Yeah. So because the compiler is going to spit out individual requests, and so, okay, the driver handles that.
Well, the thing is that the driver needs to buffer requests that refer to next objectives that it hasn't seen yet. Because you either need to put the appropriate group entry into the forwarding objective, or you need to wait for the next objective to do the merging anyway. So the driver has already got it. Do that.
Yeah, the one that we have does it one way, right? So it'll store the group. It always knows that the groups are going to come first, I think. So it doesn't, if it gets a forwarding objective, it's not going to wait for the group to come. Just assume the group is already there.
So there's no forward referencing resolution.
But you could do it either way.
Next objective need to come first, because in the forwarding objective you have to specify next ID, right? You don't create next objective, then you don't know.
And so you have to sort of install it in reverse order.
Even if you, when you're sort of like a flow that wants to group move, which is require you to put the group in.
Got it. Okay. So, yeah. So I mean, that seems to me like the most sort of natural way that would improve the overall, will improve the overall system in general, will accomplish your goal, and probably still be the least amount of effort.
So
the question is, what drivers have been tested with the flow objective and just the default?
I mean, so you're already breaking, PR will already be breaking a series of drivers potentially through the refactoring, right? Because there's a memory leak and not properly.
Yeah, it's not a refactoring, but potentially I can break something.
Yeah.
Yeah. Any concern?
Yeah. So do you have any? Do we need any CLI and the API level change in order to support it? CLI and the API level change?
This isn't going to impact the intent API. It's just a different rendering mechanism.
Or you need to have a component config to make the switch.
Well, we already have the config to switch from
Different compiler.
from flow.
Yeah, that remains the same, right?
Yeah, but I thought you were going to have a third one.
No, we just decided that we don't.
Okay.
The idea would be that the flow objective compilers could take advantage of the next objective if they wanted to, and if the drivers don't happen to support it, then that's the problem in the driver.
What was the question?
So should have a stack for.
Just speak louder, otherwise
should have
people
a
want.
stack for the drivers. For example, we need to say the forwarding object will do, and the next object will do.
Yeah, well, that's another thing in the documentation that we don't have at all.
Or people will just write their driver, and then if we change like the compiler, it will break something in the. Then you follow a stack to write a driver.
Well, at least be aware of, at least have written in the wiki, a flow objective is, a next objective is, or a forwarding objective is, just the basic in at least 3 lines of basic description would be a great thing to have.
I think I had this discussion a while back, and yeah, we all agree that it should be documented, and probably that the API is too kind of that you do like one thing in many different ways, and so you kind of do have to be aware. I know that you end up writing the application to drive at the same time because you know what kind of format you're using.
Okay.
Yeah, also, there's another problem is the next objective might very might have relationship because they might be using same group table. But if I use if there are 2 intents using same group table, for example, L2 flag table group table in the OFDPA pipeline, the 2 compilation they are not relation.
They are not.
They don't have a relation. They don't know 2 intents are.
Yeah. Well, I think the problem is that so when you create a next objective, you have to specify what operation you want to do to the group, right? Do you want to add a new group, or you want to add in a bucket of the existing group? I think this state should be stored in a higher level, either in the intent compiler or in your app. Then you know this is a bucket addition instead of creating a new bucket. So you have to create a different kind of next objective to tell the driver to modify the existing group, add 1 more bucket instead of creating a new group.
So can't we have an abstraction like automatically if the group exists, add, if the group doesn't exist, create?
Well, right now, I don't think any driver implement this behavior, right? Well, of course, you can assume like all driver does this, but right now the fact is no driver that did this, right? It's very like explicitly say what operation you want to do in this next objective. Is that add a bucket to existing group, remove a bucket from an existing group, or remove the entire group, right? You need to specify that. And in order to know which operation you want to do, you need to keep the state in a higher level. I don't know, is that intent compiler or is in your app, right? So we need that state somewhere.
Well, which is why I was asking: do we have enough information to be able to do this work below the flow objective facade, or
yeah,
need
so
to come up with something, some other?
Yeah, for example, in SEM routing, we use flow objective directly without any intent stuff, right? So basically, that state is actually keep inside SEM routing application, right? So we know what group we have already created, and if we need to add it, we will send a different type of next objective doing bucket addition instead of just creating a new stuff.
So, okay.
Do you think there's cases where multiple intents need to share the same group?
Yeah, sure, the same. Yeah, there might be some cases. For
Crosses
example,
over
you have the one intent come in and say, now I want to output to this group, this meet ID, this port, right? And then there comes a second request that I have the same VID. I want to output to this port, and I want to put these 2 in the same flag group. Then you have to do bucket modification in the flag group to point to 1 more interface group, right? So
yeah,
seems like I mean this latest point and also the next topic of discussion seem to point to some need to be able to memorize certain contexts across intent compilations.
Well, it's not even just across intent compilations, right? Because the challenge with the compiler model we have currently is one is the compilers were originally intended to be stateless. Mm-hmm. The more state you compile into them, the more differentiated behavior you get between them. But the other bigger challenge is that, we've got, a handful of compilers that are used at any given point. You may want to do resource sharing reservation and with groups, whatever, across the various compilers.
Or potential, and across potential related intents, right?
Across related intents, but they may be intents of different types.
No.
And if there are different types, then memoizing in the compiler is not going to solve that.
No.
It'll solve the problem
But I
of
mean,
sharing.
it's providing a context where the compiler can memoize and still remain stateless itself, but it can memoize into the context, and then the context, the application then essentially is what is responsible for providing that context.
Okay, so but sorry, step back, because here we focus on the intent for the next topic, but I think we would have the same problem even without the intent framework for what Charles was saying, right? Or he was saying.
I would view the reuse of groups as the same as reuse of other types of reservations.
Well,
so
sure.
we'll cover that in the next topic. But
yeah.
In the context of how do we get next objectives into, or how do we get groups into the intent framework, I think the approach that we've talked about, and there seems to be some consensus around the room on, is leverage the existing flow objective compilers. We don't need a new one.
In drivers.
Flow objective compilers.
Okay.
Generate the next objectives out of those compilers, and then handle devices that don't support groups using the drivers, the pipeline drivers, pipeliner drivers.
Any concern?
Yeah, but we haven't solved the problem that when who's going to remember the state and who's going to merge. For example, if I get the two requests coming, like all requesting to add stuff into the same class group, then who's going to do the merge?
Well, so
it's definitely not a driver.
The intent is not describing, actions that happen to a particular OpenFlow group. In the context of this particular item, we could assume that there is going to be a new group generated for every new intent. There's no sharing between the two.
Well, but you can't do that, for example, in your API, because the key is the VLAN, and you have in the flat table things are grouped by VLAN. So if you arrive again with the same VLAN, because we are using the same VLAN, you need to put buckets in the same group, right? So
think about L2 broadcast, right? When you see a new host, you probably want to add that into the same broadcast group.
But the thing is, if you don't, so we don't currently have the intent that says allow any new host to be joined into this group. You either have an intent that says these are the 3 hosts or the 2 hosts or the 5 hosts that are going to participate in this intent in this particular traffic pattern.
But I again don't see why we go for this specific thing at the intent layer. For one time, the intent in my mind are not related to this thing, right? If I create a group in general, right? So we're talking about the thing that I have a group at the lower layer in the southbound. I don't have a way to specify use this group or create a new group. Delete an entry from the group or delete the entire group. I think that's the problem, right? It's not really at the intent level. The intent in my mind should remain as they are.
I don't quite understand your question, because we do support that in the driver. If you put the right operation in the next objective.
Well, if you are coding in the driver, yeah, but we just said we don't want to implement it in all the drivers, right?
Yeah, but how to pick the right operation in compiler?
That's your app's intelligence, right? Like your app needs to know what to do.
So the app, there exists a group there, so you can pick.
Now, of course, your app knows everything, right? Including your previous requests. So you already know you push a group over there. Then if you need to add it, then you just send a flow objective saying, oh, my operation would be editing the bucket and add one more bucket to the existing group.
Yeah.
Right? But either this kind of merging intelligence need to be in either the app or the intent level. I don't know which one is better, but I mean, it's definitely higher than driver, right? Because driver already allow you to specify the operation. You just need to give it the right next objective, right? So someone has to create the right next objective, and who's that?
The some application just use intent. They don't know what compile to flow or objective.
So in that case, intent framework should do that. The compiler should do that.
Well, the compiler is the application here, right?
Sorry?
The intent framework group of compilers is the application
Exactly.
that is managing the flows, and in this case, the groups.
Precisely.
Okay.
But
So in this context, somewhere within the intent framework, we'll need to figure out how to reuse groups.
Yeah, I think that's
and
a
apply the
compiler, right?
appropriate-
When you compile a new intent, you already have the existing intent that already creates this kind of group, and you can reuse that group.
correct, except the compilers were purposefully designed to be stateless. So I
Right.
don't remember it.
And
But,
the
so we
other-
need to.
The other challenge is that this type of reuse you'd probably want to permit across intent types. So it's not going to be per
No,
compiler.
that's which is why I suggested, and I think the next point of
That
discussion
can be a
will be
resource.
exactly the same thing, is to come up with an abstraction that represents some sort of a compilation context, which an application can supply, or through which can potentially, if you supply the same context across multiple intent compilations, then potentially not only different kinds of intents, but also potentially different instances of intents. The compilations of those can share the same context and potentially make basically share state across. Of course, this is something that, I mean, I don't want to jump too early to the next.
No, well,
We can say that later, but
because
I'm thinking that probably the answer lies in to both of these problems lies in introducing such a sort of a separate stateful entity, which can be how it's shared can be controlled by the application. It's given to the compilers, and compilers can use it as essentially as a place to memorize and also to get hints from as they drive the compilation process.
So that entity will somehow contain things that are in common to multiple intents or multiple things, multiple requesters.
Yeah. Now, the question is, how flexible does it need to be, right?
Right.
Is it sort of like a general purpose scratchpad, which of course that entity needs to be serializable, because it needs to be submitted along with the intent,
right.
or may need to be attached to an intent for as it's submitted to the framework. So it needs to be serialized across the cluster because we don't know where we're going to be processing the intent.
Okay, so I would suggest just to answer our first question, we got an answer to what we were asking, right?
Yeah.
We know what to do. We know how to move forward. Well, at least at high level.
We need something.
Well, you have a part of the solution, right? Part of the solution would be to modify the compilers to emit next objectives, properly structured groups, in addition to the forwarding objectives. But I think that's only part of the picture. The other part of the picture lies in the fact, well, what are, how to enable sharing of groups among intents or evolution of an intent across time.
Yeah, I think there's one part question. Intent framework remove the flow objective. The compiler should know to record it.
Sorry,
if the intent framework remove the intent, so you also remove flow objectives and the groups.
Well, that's the compilers.
So the compiler should know.
No, but someone must request this removal, right? And that removal should go through the compiler, right? So why the compiler doesn't know?
Well, go through the compiler.
No, the removal will basically just take the resources that the compiler previously generated and apply.
Actually, groups would become essentially a tracked resource, right?
Sorry?
Groups would effectively become a tracked resource.
So the resource you put in the intent framework, not compilers. I mean the groups, the data.
I don't quite understand the question.
Also today we have intents. We can annotate intents with a number of sort of constraints.
Yeah.
But also as part of compilation, the intents can also reserve certain resources. groups will in effect become resources, but they might need to be shared like other things potentially, so that they're not so so that that one intent does not solely occupy a group, for example. Because right now, I think the way the intent compilation works is the resources are exclusively allocated on behalf of each intent, right?
Yeah. So,
which hence the second point of this.
Yeah, I guess it's time to move to the second part. Okay. I have a very short presentation for it to describe you the problem. Why do I still talk?
That's because I'm.
Oh, okay. That makes sense. Okay. So go away. Okay. Okay. So today we have a patch, very basic, simple patch sitting in Gerrit. Okay. What that allows to allocate bandwidth on intents. It's very simple. Basically, when you create an intent, you put a bandwidth constraint. Okay. You say my bandwidth constraint is 100 bit per second or whatever. You add the bandwidth constraint to the intent. You build your intent. You submit it. When you arrive in the intent compiler, we observe all the links that form the path of the intent. Link by link, we get the connect points for the bandwidth, for example. We go connect point by connect point, and we say, we ask to the resource subsystem, do we have enough bandwidth on this connect point? Yes or no. If we have enough bandwidth all along the path, we go again through all the connect points, and we allocate the bandwidth, specifying an intent ID, which is the requester, the connect point where we have set the bandwidth, and the bandwidth value. Okay?
You need to allocate like in one go, no, right? At the
Yes.
end, you'll
Yes.
allocate like step
Yes.
by step. Well,
Yes.
anyway, okay.
Sorry, I just put it like this for,
It's kind of optimistic blocking, right? The initial pass is.
Yeah, but I think the resource subsystem allows to
Yes.
give you a list of things you want to allocate.
yes,
And
before you go,
transactions.
they all go or not, yes.
Yeah.
Okay.
yes, so before you essentially define all the resources you want to allocate, and then you say allocate these resources. Yeah. But anyway, this is what we do. The patch is there under review. Okay.
Is it, what's the reason why these bandwidth constraints are separate from intents? Or is it because they're shared across multiple intents?
No, they're not.
Why aren't they just part of an intent?
So that's in the first two lines of code. Intent is an intent builder, I'm assuming.
Yeah.
And the bandwidth constraint that he's describing is just an additional constraint that's being put into the intent.
So they are part of the intent.
So they are part of the intent. Yeah, sorry.
The high-level constraint is specified at the intent level, but then needs to be for the reservations. Then need to be done on the path.
So I guess what I don't understand is why is the client of the intent worrying about reservations in the intent?
No, this is the compiler.
So the ... it means,
yeah.
Something that happened there was a submit to the intent framework picked it up,
Oh,
and then now we've
This is the call stack, not linear code.
The client is just
That baffled me.
and everything else. There's also a bug in there. You should unline like.
Okay, let's move forward.
There's a few problems with your code.
Okay.
No chance of understanding.
Don't worry. So, okay, first problem of this thing. Imagine we have a single on the left, okay, time 0. We submit an intent from A to B and C. So source is A single point to multi-point intent that goes to B and C. Then another host comes in, D, on the right, okay. What we do today from the applications usually is not withdrawing the old intent and create a new one. what we do is just to submit another intent with the same key, but that has just another connect point into it. Okay. So what happens is that it goes through the same pseudocode you saw before. Okay. And what happens is that for each connect point with that code, we allocate essentially the bandwidth twice, which is not correct. The thing.
But it is correct because you asked for an additional path with the same bandwidth across from like 1 to 2, right? So you that seems like correct behavior to me.
This is what, single point to multi-point or something?
Single point to multi-point.
So in this case, you have like a broadcast intent, not broadcast, but like a multicast sort of, where you have a single speaker A on the left, and you need to be able to deliver 10 megabits per second to B, C, and D.
Oh, yeah. I see. So you're saying that the way the semantics for this multipath intent are end-to-end, not link semantics.
Yes, correct.
Because the link semantics look totally correct.
If what he did here was add another one there.
Saying like for this, so it's like give me this tree, and then I shift parts of my tree so that links are shared. It's pretty clear that if you want complete bandwidth on the tree, you're going to have that bottleneck link need to have double the bandwidth.
Yeah, but in this particular intent that I think he's talking about, the semantics is like you can imagine A is sending to B, C, and D, and so the data is not actually duplicated across. The data is copied, not individual streams to each of them.
Right. So what you seem to be saying is that there's a sort of disconnect between the packet replication that happens on switch 2 for your multicast tree,
yes,
and the bandwidth allocation.
Yeah. So for this problem, I came back here. For this problem, I have just a quite simple solution, I guess. While I loop through the connect points right now, as you see, when I allocate the bandwidth, I specify somehow also the intent ID, right? And I can also query the resource subsystem, I guess at some point somehow asking what resources have been allocated from what intent IDs. So in this simple case, I can just say if the intent ID was the same, I hard code the behavior of saying if the connect point is the same of something you have in the store and the requester intent ID was the same, don't allocate the bandwidth twice. Okay. This is kind of already an hack, but somehow it would work. I show you a more articulated use case. Two intents sharing the same connect point. Now, don't enter now in the matter of why I might want to do this. Okay? So because give me a second, just because we would spend all the DSP just discussing about the why and what. But for somehow the application needs to have two intents, one that connects A to C, the other one that connects B to D. At the edge, of course, A and B are connected on two different ports, and C and D are connected to two different ports. But in the middle, the link is shared. And on that port, the bandwidth needs to be allocated just once. Okay?
So this would be sort of, we don't have a mechanism to describe this in the existing intent description, right?
We don't have a mechanism
there's
for
no,
what?
There's no way to say that I want two intents and I want their resources to be shared.
Yeah, that's what we are talking about. That was the question of the TSP.
But the thing is, what constraints do you put on the intent? Because the constraints you have to put on the intent is, I want from A to C, I want 10 megabits, and from B to D, I want 10 megabits. But really, you want that to be shared. That's like violating what you just requested in the intent.
So the couple of things. The number one, I think the intent bandwidth is the logical views. Okay, so the physical view is basically it's a physical network, right? So when you allocate the logical views twice, intent basically they were mapping to the physical ones. You should mapping the twice. Here is the example. Okay, I want my stream allocate the 100 meg. Okay, the second stream coming and say, I want to allocate another 100 meg, right? That aggregate is twice. Why you want to combine both?
No, he doesn't want to combine both. So, correct me if I'm wrong, but to paraphrase the use case, at least the way I understood it when you talked to me this morning, was, let's say you want to construct a high-level entity, let's say virtual network or something like that, which, and in order to materialize it, you're now using intent subsystem, and so you're issuing a number of related intents, but the overall, you really don't care how compromised the individual intents. You want to share you really want to share the resources between them in terms of the.
What you're saying is, okay, I'm going to use 12 intents to create a virtual private network.
Exactly.
I want this virtual private network to consume no more than 10 megabits per second on any one link.
Yes.
And gets a minimum bandwidth of 10 megabits per second on every link it touches.
Yes, exactly. Yes.
And so in that case, I mean,
we don't have a vehicle.
We don't have a vehicle to describe it, and
exactly.
Putting those requirements on each the constraints on each individual intent doesn't seem to do it justice. Correct,
because you will severely over-provision, potentially blow out your physical limits.
And also violate the high-level policy, which you described, which we can't today describe using intent.
I don't have a good feeling of like what policy you're trying to. I mean, or like what's the what are you really trying to get? Or
you're trying to compose a high-level intent from two low-level intents. It's effectively what Luca is trying to do, and we don't have a good building.
It's not even that though. What I think Luca, my understanding of what you're trying to do here is for you're basically saying that you want to sort of a maximum limit for non-bottleneck resource and a minimum guarantee for some bottleneck for certain specified bottleneck resources. So it seems that's something that I can understand and I can imagine specifying. Is that actually what you're trying to do, or are you trying to do something else?
Hold on, I'm trying to elaborate in my brain what you suggested.
Yes, but with boundaries. The problem is what you described, sort of minimum guarantee but maximum consumption, right? But it needs to be done only in a context of certain related intents, not across the board.
I guess
we have nothing to tie the intents together.
I guess another way of putting it is maybe min-max is confusing. I mean, I guess the use case seems to be, I have some critical shared resource that's a bottleneck, and I want to basically limit my virtual network's use of that bottleneck resource. And that seems to be
So I'm not sure what.
I mean, I guess unless we understand the problem, and the way to specify.
So
the
thing is, what you said is correct, except some virtual network. You said some virtual network, right? So, but you could effectively think of that virtual network as a high-level intent.
Sure. It could be connectivity intent.
And so we don't have so while the policies are sort of a policy to saying this network will serve this much connectivity, across the board, up to this much connectivity. Whether or not sharing the resource or not, it doesn't really matter. But overall, you just want to be able to express some constraint on that high-level construct. And we can think of that high-level construct as an intent, even though that's not what it is today. And that needs to be comprised of some other intents down below it. And we have nothing to tie it together. Now, I don't think
Can I just try to rephrase that? So, what you're doing is you have a high-level thing you're trying to express. And the way that you're expressing it is through lower-level intent as building block. Yep. So in this case, one way to build a virtual network is to create n squared over 2 intents, n times n minus 1 over 2 intents between every possible pair, which describes the connectivity that you want. It's not probably the most efficient or optimum way to do it, but it's a mechanism of describing the connectivity. Yep. Now, you also want to describe an aggregate bandwidth that is permitted for this virtual network across every link that this intent happens to touch. So you have, a bandwidth on every link that you touch. You want, the connectivity that shares a bottleneck link to use, up to and no more than a particular amount. And so in this case, really the challenge is we need to be able to express constraints above the intents that you're using to describe connectivity. Because if we're going to allow people, and this kind of plays into some of the building block stuff we've talked about, if we're going to give people a bag of building blocks with which to build up connectivity or forwarding within their network, they need to be able to express like high-level policy, which describes, you know, the entire picture, as well as to potentially use the building blocks to express pieces of that picture which can be composed.
Yeah, I agree. The question is, what are those building blocks?
And so at the moment, you know, we don't really have the composable building blocks that, you know, we hope to have in the future. But what we do have is we have point-to-point, multi-point to point, single point to multi. We have a variety of these building blocks which do describe some degree of connectivity, and they can be glued together at this point with flow rules if you really wanted to.
I think over here, so sort of from the QoS point of view, you have the three things. Okay, keep this in mind. Number one is you allocate this intent, you want to guarantee the bandwidth or not. Okay, if you want to guarantee the bandwidth, each one should guarantee what you allocate, what you want. Okay, if you are doing just the best effort, basically it's like a brand that is shared. It's who coming first to take over this one. The third one is low latency, right? So this pretty much depends on your underneath. Number one is the hardware support. Number two, from software control plan level, you need the policies. I completely agree with the franchise policy to do the aggregation. You cannot exceed the bandwidth. If it's a gig, it's a gig interface. So the aggregated the bandwidth should not exceed the gig. It depends on your guarantee or it's the best effort. Best effort can share. Guarantee you can. You need to allocate to whatever you ask about.
Yeah, but okay.
I mean, one way we could potentially explore like a straw man proposal here would be you have like some mechanism for providing relations between intents. Like when you're defining an intent, you can either point to children or you can point to parents, something like that. You should kind of, you know, build a sort of hierarchy. And the idea, you know, you'd have to define the semantics, but something that could be done is, you know, if a constraint is expressed explicitly on a particular intent, then that constraint should be accounted for that particular intent. But we may also want to consider the constraints of parent intents. For example, if, you know, your application wants to block all traffic to a particular port, you know, the internet, something like that, then that may be a constraint about a connect point or a link that can or can't be used. And then all intents that are being realized could inherit the constraints of their parents, so to speak. It would make compilation a little bit more difficult. I'm not proposing this as what we should go forward with, but you could define some semantics where children share the resources of the parent with the parent. You could have an intent type which, you know, doesn't explicitly define any new connectivity, but is, you know, simply a placeholder for the types of constraints that we're talking about that could be evaluated in the process of along with the constraints of the leaves.
So the brain is if the requirement here is to do the guarantee the bandwidth, basically you need hardware support.
Okay, but you're talking about another thing. We are talking about two intents that share a generic resource. Okay, this is an example. Take it as an example. So don't take care of the use case now. Resource could be resource could be a group. Resource could be whatever. Is a share. Delete it. This is an example. Okay, a resource in general.
But in the case of bandwidth, Patrick, yeah, agreed. If you don't have an enforcement mechanism and you're asking for something that exceeds reality, then you're not going to get your intent compiled.
Yes.
But assuming you do have an enforcement mechanism, which we're working on building, and assuming your request does not exceed the physical available capacity, then we could allocate that bandwidth for an intent or an intent group.
To the top levels, we definitely need to answer the questions like when you allocate the intent, it's all these resources are shareable or allocate specifically for each intent. Right? It's guaranteed or it's best effort.
So at the moment, we only allocate resources on an individual intent basis.
Okay.
We also, even though we do have a bandwidth constraint, we don't actually, bandwidth is still best effort. We don't have an enforcement mechanism. So there's two challenges here, and we're not talking about the enforcement mechanism as part of this conversation. We're merely talking about moving to a model where resources can be reserved outside of a single intent request.
So the reserve, that is the guaranteed, right? If you do the
logically reserved.
Yes. In the beginning, I said it's the intent level resource is the logical level. So it's not the physical level. So the mapping is the mapping to the physical level is a job done by the compilers, right? So what we are talking about is
so they want to share a logical reservation.
Okay. Share the that is okay.
I think the things you said are all good. Like you said, overall, it's what I was trying to ask Luca at the beginning thing, which is that is this idea that that resource reservation can span multiple intents or not, and sort of what's the logical model of how to specify this, and you can really figure out what you want and a way to specify it. That seems like a really important question to answer. And then what Brian was saying about different possible thinking about what are different thinking about this problem at both the specification API level and the implementation level. How do you make it easy? What are the building blocks? How do we specify? How do clients or applications specify what they want, and how does the intent and resource reservation system deliver that to them? It seems like it'll require a fair amount of thought. But I think some of the ideas you said make sense and are worth pursuing.
So one possible sort of evolutionary type approach, maybe not an ideal one, but still something that's not necessarily very hackish, but also something to be accomplished in a reasonable time frame in an evolutionary fashion with respect to the existing framework, would be to provide that sort of this look-aside context that could be bound to the intent. It's still in a control application, control of the application, and it can be used both as a vehicle for the intent compilers to memo our state across different compile runs, as well as potentially as a sort of an additional sort of a hint vehicle for application to specify things.
So again, okay.
But for example, in this case, right, simply giving two related intents the same compilation context could be used as a vehicle to limit the basically share bandwidth reservations if the compilers were written that way, right?
one thing, right, is that it's not just like we also let me take it so I can try to rephrase this. In the case of shared resources, you don't want those shared resources to disappear until the last one that consumed them disappears. And so in the case of this, right now, if you gave a copy of each of these reservations to each of the intents, when those intents are withdrawn, they may pull rules, they may pull groups, they may pull bandwidth reservations out from other existing intents. And so, I don't know. I mean, these sorts of contexts could also be used potentially, like when you're allocating something, figure out if it's already been allocated on behalf of this group. Am I the last user?
Exactly.
That type of stuff.
Exactly. It's basically like just a little bit of a
reference counting context
Yeah,
for
exactly.
shared reservations or something.
Because I think we definitely need to keep the intent compiler stateless. I think introducing stated then would sort of undo a lot of the benefits of the original design objectives. So.
Something I'd like to see from you, Luca, is, your view on how you'd like to specify this. Like, what would be the convenient API that you would use to specify it? There's sort of another approach in addition, perhaps orthogonal, hierarchical intent, but more on the side of logical things. The question I asked is, like, what's the right abstraction? Certainly, one might argue that, well, maybe the right abstraction for creating a virtual network is a virtual network.
So virtual network intent.
Yeah, something like that. Maybe that's sort of so there may be multiple ways of multiple abstractions that could be used for these sorts of things. And I think it's worth investigating all of them and also sort of thinking about what's the problem we're trying to solve. How, if we, ONOS could give you whatever you wanted magically, what would be the best possible thing that you would want? And I don't think we have a good answer for that yet.
So, with respect to sort of the time for this meeting and maybe a proposal going forward.
Yep.
I mean, in general, sometimes we have good discussions in TST meetings, but we somewhat lack follow-up.
Yep.
In this case, I think number one, we've more or less understood the problem and come up with a solution. For number two, I think we've started to expose the problem. I think you did a pretty good job of trying to introduce the problem. But as Bob said, and I think as others have alluded, the solution may be a bit more complicated. And so what I'm proposing is, I mean, I'm happy to participate in this, but maybe a quick summary of the problem sort of restated under the context of the meeting, as well as a more technical proposal for the next TST meeting, or if it's not next one, the following one. But it would be nice to have some continuity on some of these issues. And so I think in general, if we can't reach a consensus on a particular issue, then we should try to put that at the top of the next agenda. Not spend half an hour or 45 minutes on it, spend five or 6 minutes.
Okay.
And go.
It seems pretty clear to me that some additional brain power needs to be applied to this.
But just the fact of discussing with you and exposing the problem, right? It's best because when you do things on your own and you are just on the keyboard, you talk just basically to your own, and things don't come out. But if you talk to other people, it's always good, right?
Well, yeah.
So
I want to have, at some point, do some additional homework, but in background work, but like schedule a meeting to talk about this. It could be formal or informal discussions. But I think more discussion with multiple people would be productive.
Yeah.
The other thing, potentially around agenda making, if the meeting is going to be at the same time every week, instead of having in some cases we have remote presenters that have particular constraints in terms of days, and maybe we give priority to them. But in general, if there's a running backlog of topics, including topics like this that are going to get re-injected, it might just make sense to look at a backlog at the beginning of a meeting, cover the items we can get to, unless there's particular dependency on them, and then kind of move forward, especially if we can kind of get the same group together every week. Because before it was like, if you miss one time zone, then the next one, and maybe we skip a meeting, and a month later you finally.
All right. Well, thank you.
No, thanks. Okay. All right. Bye, everybody. I'll upload this shortly.